Hello, algebra students, and welcome to your third day of 11.9. I think I talked on our first day of 11.9 how important solving radical equations is, and that we'd be doing it for quite a few days. So we're only on day 3 with many to come. But our essential question is going to change a little bit today. I'm going to ask you, can I solve equations with x to the power of 2, or x squared? And why is this called a radical equation again? If we look back in our notes, we'll notice that the inverse of a radical is squaring, the inverse of squaring is a radical. So even though it's called like a radical equation, it can have a squaring. Just like if we had a multiplication equation, we would undo that multiplication by division. So we have this x squared. It's a radical equation even though it's going to have an x squared in it. And let's back up just a tiny little bit. Write this all down for me. And then I want you to pause and think. I actually want you to set down your pen and think about it for a second. What number would go here? What to the power of 2 gives you 100? And I'm hoping that a majority of you would say, well, 10. 10 squared is equal to 100. And I would say, you are right. But maybe 20% of you know, maybe now 25, now that I'm slowing down, there's another number that could go there. Maybe 30% of you have figured it out. What other number multiplied by itself, that's what x squared means, gives you 100? For example, 100, squared gives me, or 10 squared gives me 100. But if I take negative 10 and square it, that also gives me 100. So negative 10 could also be another answer, and you'd want to make sure that it's in parentheses because order of operations says you do everything in the parentheses first. And if it was not included in the parentheses, that negative, you'd actually square the 10 first. So the whole negative 10 is in the parentheses. We need to use this piece of information for our next step. And I'm going to show you an example. So we're just going to start with example 1. You might see a problem that looks like this. That could be a problem. And I'm asking you what x could be, just like how I did up here. What could x possibly be? What number could go here? And I'm hoping at this point you would say, well, 2 squared is 4 and negative 2 squared is 4. So we have our inverses. The inverse of squaring is square rooting. So we square root both sides because that's going to get rid of the squaring. That goes away and I'm left with x. And now what is the square root of 4? Well, that's 2. But x is not just 2, just like how we did up here. What number could x also be? X could be a positive 2 or a negative 2. And we call this a plus or minus sign, plus or minus 2. I've had students in the past call it a plegative, like a positive and a negative. I don't care what you call it. But it's technically, mathematically, a plus or minus 2. So when you take the square root of both sides, and you're looking for x by itself, your answer is going to get a plus or a minus of whatever that square root is. So let's start off with some steps. When you see an equation that has an x squared, you need to get the x squared, or like whatever is squared, and we'll get to that later this week, or I'm sorry, next week, by itself. In that case, it already was done. Check. Number 2, square root both sides to undo or get rid of the squaring. And then set answer as a plus or a minus. And we're going to see what another example might look like following those directions. So let's look at a problem that looks like this. 3x squared is equal to 27. So let's go through this. We need to get the x squared or whatever squared by itself. Has that happened yet? No, it has not. So how do I get that x squared by itself? There's an invisible multiplication symbol right there. So we're going to divide both sides by 3. And that goes away. X squared is equal to 9. Hey, we did it. We got the x squared by itself. Next step, square root both sides. I'm going to use that blue again. Why did I square root it? It's because it undoes that squaring, and I'm left with just an x. And what is the square root of 9? The square root of 9 is 3. But what am I missing? Correct. When I square root both sides, that's a plus or a minus. Because if we go back to this problem right here, if I get, you don't have to write this down, but if you get x squared is equal to 9, that x, what could possibly go there? 3 could go there, or a negative 3 could go there. That's why your answer is a plus or minus 3. So let's try 1 or 2 more to just see some examples of what this would look like. Example 3, 2x squared plus 1 is equal to 9. Okay, I want to get the x squared by itself. What is my first step? Subtract that 1, because you always get rid of something that's the farthest away first. It's still not by itself, so I'm going to divide both sides by 2. Okay, did I do it? I got the square root, or I'm sorry, I got the x squared by itself. So now it's time to square root both sides. Done, awesome. Oh, sorry, that crosses that out. X is equal to, what is the square root of 4? 2. Why is that wrong? Because what could possibly have made this equation true? Well, 2 squared is 4, but negative 2 squared is also 4. So you get a plus or minus 2. I'm running out of room, so I'm going to do another example over here. And this will be our last one. 5 squared is equal to 3 squared plus x squared. Is x squared by itself? No. You know what? This might be easier. Why don't we change this to numbers? Because if we can, why not? That's going to be the easiest way of doing everything. You could write like 5 squared minus 3 squared, but this is way easier. So x squared's not by itself yet. We got to get rid of that 9. So I'm going to do that there. Hey, now we did it. The x squared's by itself. My second step is to square root both sides. So I'm going to do that. That gets rid of that squaring. X is equal to, what is the square root of 16? 4. But what squared gives me 16? A 4 does, but a negative 4 also does. And I always like the x on the left-hand side. There you go.